Alright, welcome to the discussion for Math 980 2.4 on equations with absolute values. We'll do a couple of the problems in this section. The first 5 or so shouldn't have given you much trouble. They're pretty basic, so let's start perhaps at 6. 6 is still pretty basic. It just simply asks you to solve for x. And it has the absolute value of x is equal to 5, right? And so you think about this and just say, well, if x is 5, then this is true because the absolute value of 5 is 5. But x could also be negative 5, and so because the absolute value of negative 5 is also 5. And so that essentially is how we split this into two things, is whatever's in the inside here is either the positive value of this number over here, or it is the negative of it. Right? And in this case, we're done. That's our solution, right? You just need to make sure that you put these in order because it asks you to put the smaller number, which is the negative 5, first, and then the larger number, and that's the 5, right? But this kind of idea carries on. They get a little bit more complicated, of course. Let's take a look at number 8. In number 8, we have a bunch of other stuff hanging around first. So I've got this 15 minus 3 times the absolute value of 4x minus 2. And that is equal to negative 27. Okay. So you'll want to clear out all of the junk away from the absolute value before you break it into those two equations. I'm going to start here by subtracting 15 from both sides. And again, don't try to do this 15 minus 3 because you can't. This 3 is kind of hooked onto this absolute value as a multiplier. So I can't combine these, right? What I want to do though is minus 15 from both sides. Gets the 15 out of here, and it leaves me with negative 3 times the absolute value of the 4x minus 2. And that's equal to negative 42. And I want to get rid of the negative 3 now. It's being multiplied by the absolute value, so I get rid of it by dividing. So minus 3 divided by minus 3. The 3 cancels out, the negative cancels out. That leaves me with the absolute value of 4x minus 2 is equal to, the negative cancels out here, the negative cancels out there. That is 14? Yeah. Yeah. And now I need a little more room, so I'm going to take this up and put it up here, but I've simplified it down to similar to, number 6. I just have the absolute value of something a little more complicated than x, but it's still just the absolute value of some stuff. There's some junk in there, and therefore I can turn this into my two equations. Whatever's on the inside is either 14 or it's negative 14. So that means that I have 4x minus 2 is either 14 or that expression, the same expression unchanged, is negative 14, right? And so if I add 2 to both sides, this gives me 4x equals 16, or still, and I'll have whatever happens there, divide each side by 4, and that gives me x equals 4. Or add 2 on this side, that gives me 4x equals negative 12. Divide each side by 4, and I end up with x equals negative 3. And again, you can take those, plug them in, check them. But remember, it says smaller value first. This negative value is the smaller value, then the positive. And that's it. And then we had something pop up like, say, number 12. 11 and 12 are similar. Let's take a look at 12. So 12 says the absolute value of 7x plus 1 is equal to the absolute value of 2x plus 2. Right? And if we kind of just stop and simplify this just for a second here, something simple like the absolute value of x is equal to the absolute value of y. What can you say about these two things? Well, either x and y are the same number or they're opposites. So there's really just two cases here, right? So that's all I really have to consider is either whatever is in here, this 7x plus 1, is the same thing as 2x plus 2, or it's the opposite of it, right? And that's my two equations. So I'll write that. Keeping 7x plus 1 the same, 7x plus 1 is either equal to 2x plus 2, or 7x plus 1, that same expression in here, is equal to the opposite of this, and the opposite of 2x plus 2 is negative 2x minus 2. It's like you're distributing a negative through this. Okay? And that's my statements. Right? I'll start with the left one, solve it by subtracting 2x on both sides to get the x's to the left. Subtract 1 to get the 1's to the right, or the non-x terms to the right. Right? This leaves me with 5x equals 1. Divide each side by 5. I have x equals 1/5. Or add 2x to both sides. Since I'm bringing my x's to the left again, I'm going to subtract 1 from both sides. This leaves me with 9x equals negative 3. Dividing each side by 9 tends to x equals negative 3 over 9. That can be simplified to negative 1 over 3. And I have those two solutions. Right? The smaller number is the negative 1, right? Negative 1/3, and then 1/5. Thank you, and I'll see you guys for 2.5.